Hi, welcome everyone to Luminescene Nigeria Limited Solar Installation Training. This is the beginner course, and without further ado, let's dive right into why we are here. So, in this chapter, we'll be discussing how to properly size your solar system. So, just to note, there are three main solar system designs. We have the grid tie, we have the hybrid system design, and we have the off-grid solar system design. So in this course, we are focusing mainly on the off-grid solar system design. All right. So everything we talk about here will be solely based on this. So you cannot mix them up. The designs for the hybrid is different from design for the grid tie. So in no case you shouldn't mix them up. So particularly because this is a beginner course, we'll just take one course. But when you come in fully, we'll discuss everything. So let's get straight to the point. All right, there are 5 steps you should know to design to design is an off-grid solar system. So there are 5 steps to know to design an off-grid solar system. So first thing is to know your load. You have to know your load and know how to analyze your load. From your load, you derive the sizes of your solar panel. That's number 2. You derive the sizes of your inverter. You derive the size of the charge controller, and you derive the size of your battery. So before we get into that, I would like to show you what these things look like. I'd like to show you what a battery is. I'd like to show you what the solar panel is. I'll show you how an inverter looks like. I'd like to show you how a controller looks like. So, alright, with me, this is a very small compact inverter. This is a 500-watt inverter. So with me, this is a 500-watt inverter. It's very small. It's very small. So this is a 500-watt 12-volt inverter. So inverters are rated in wattage and they're rated in voltage. So this is a 500-watt 12-volt inverter. This is just an example of inverter. All right. Okay. This is a solar panel. A solar panel. This is a 100-watt solar panel. It is indicated at the back here. This is a 100-watt solar panel. So just in case you can't see that, but just trust me on that. This is a 100-watt solar panel. We have a solar charge controller. This is a PWM solar charge controller. During the main course, we'll be talking about the type of controller. Same thing, the type of inverters, types of panels. So this is a PWM solar controller. This is 50 amps. They are rated in amperes, while the panels are rated in wattage. And lastly, I will show you what a battery looks like. I believe you already know what that is. Okay, so this is a 100-ounce battery. It's quite heavy, so this is a 100-ounce battery. So without further ado, let's get straight into each of the steps. So I said first is load analysis. Know your load and analyze your load. Second is to calculate for your solar panel array. And when I say array, I mean set of panels. So this is just one panel. So if your design requires you to have more than one panel or 2 panels or 3 panels, so everything will be right, everything will be right based on your panel on your design. The next thing is your battery bank, and battery bank. Next thing is the charge controller size. It comes in amperes: 30, 50, 60, 100, 120. Next is your battery. So yeah, please let's recap: load analysis, solar panel array, charge controller size, battery size, and inverter size. So these are the 5 steps. Very important. So all right. So first of all, you will list the appliances you want to power, and when you list them, you will check for the wattage. You check for the wattages of the panels. So for example, I have, let's say I have, these are my loads. I want to power one television set. I want to power one ceiling fan. I want to power two lighting points. And maybe what else do you have? Okay, let's say this is just all on power. And let me say one decoder. So now the first thing we've done here is to list out our loads. Next thing is to now, you know, look, we need to know the wattage of each of these loads. Now, a very simple way to check is you can just go to the load and just check on the body. I think for a TV behind it, you'll see the wattage of the TV there. And in case you don't see it, you might see voltage and amps of the appliances. Ceiling fan 2 on your carton is written there. The lighting point on your bulb is written there. And your decoder is written there. Or you can just just go to Google and just check LG 24 inches smart TV. It gives you wattage there. So it's very simple. So for example, let's say on our TV, we don't see the wattage there. We see 220 we see 220 volts and we see 0.5 amps. So I don't know if you remember Ohm's law back then in secondary school. Ohm's law. So basically, to know the wattage, watt is equals to voltage times current. So 220 volts times 0.5 amps will give us 110 watts. So this is assuming you do not see, you do not see the wattage written of a TV set on the TV. For a ceiling fan, let's say you've checked everywhere, you didn't see it, and you check on Google, and it tells you that a Casa ceiling fan is a Casa ceiling fan is 80 watts. The lighting point, let's say on the bulb, you see that it is 15 watts, and we have two bulbs there, which is 30 watts. And decoder, same thing. Let's say we see that it is 30 watts. So now this is the process of us analyzing our loads here. So we have already begun our design. This is the very first step you need to know. So I'm going to give you a formula to derive. I'm going to give you a formula to to know your daily consumption. So now we have known this. The next thing we need to know is the daily consumption of these appliances. The daily consumption of these appliances. So the formula for daily consumption
Daily consumption is equals to appliance power times quantity times power times quantity times hours of usage. All right. So let's take this example now. It is a house, and we watch TV in the house for about 4 hours. So let's give this 4 hours. We have one TV, a fan, let's say 8 hours, because sometimes we want to sleep with light with fan. So let's give this 8 hours. Lighting points, let's give this 8 hours too, or less 6 hours. Let's do 6 hours. Decoder is on with TV, so we'll give that 4 hours. Alright, so using this formula, for our TV set, For TV sets, appliance power is 110 times quantity, just one television.
So based on the formula, daily consumption, appliance power times quantity times hours of usage. TV set 110 watts times 1 quantity times number of hours, 4 hours. So this is 440 watts. Ceiling fan, we have 80 watts times 1 times 8 hours. So this is 640 watts. Then lighting points, 30 watts. Okay, 15 watts. Quantity is 2 times 6 hours is 30 times 6, 180 watts. And for our decoder, we have 30 watts times 1 times 4. So this is 120 watts. So to know our total daily consumption, 440 plus 640 plus 180 plus 120. So we have 1,380 watts. Sorry, watt hour. 1,380 watt hour. Why we are including hour here is because wattage times time. So I should have included all of this here. Watt hour, watt hour, watt hour. Total consumption is 1,380 watts. So let's keep this at the back of our mind. We are done with the load analysis.